Okay. I wanted to stop by. No worries. No worries. Look at the colors. So absolutely, thank you. But we're gonna be here. We're gonna be answering questions. For anyone, you should be good to go. Thanks. I don't space to keep this here. Okay. So what is actually draw? Do you want to draw? I'm gonna draw one. Okay, and the other one. Come closer. Closer. Yep, perfect. This is our space. We can totally do it. Yep. Hey, work. You know. Congrats on the deal job.
I'm Sean.
Sean.
Yes, sir.
I have to email like 3 or 4 people to make sure that I get the right person.
No.
Thanks.
What are the, how you guys doing this? Almost towards the end, just I had trouble on the input. Oh, like so the yeah, but this is a test. You're adding that actually.
Are you moving? Okay, let's get started. Good afternoon, everyone. I hope everyone had a great weekend, because I did. We were actually here in the same room. We were doing the hackathon, and some members came, and some other people are unable to make it to class today. But I am, thank you for those who were able to come, and thank you for those who were not able to come, because I know you would have wanted to come, except you just couldn't. So maybe next time. But it was a really great weekend, because one of the advanced data science students that sit with those people here was designing a tic-tac-toe game. And as I was explaining to the people in my CS100 this morning, this is a game that is very well known of being 3x3, but Carlito was designing a game that is scalable for n by n, 100 by 100. So a very challenging game to design. There was a lot of math equations were written here on the weekend. Apparently somebody cleaned them, thanks to them. And it was just a great event. We grabbed some breakfast. I got in the best Montreal style bagels from the Burlington area, and they were right here. There was plenty of bagel for people to eat. And we also got in some pizza in the afternoon as well. So it was a really great event. And it's less formal. You're expected to be formal in the classroom, especially if you're in the military lifestyle. But the hackathons are kind of a lot less formal. Very casual, very friendly. You can talk to me without the word sir and have to be, very military proper thing. I appreciate both, and I'm happy to be treated both. But it's just a great opportunity for you to not only interact with me in a closer, from a closer distance, and also see how other people are talking about problems to solve, and what fun things can you do if you have a weekend that you wanna enjoy yourself. This morning I was actually teaching problem solving to my CS100, and we have a very bright student here who actually said one of the problems that he wants to work on is essentially predicting the gas prices based on some events. And a lot of other topics as well, and I believe some other people brought up the idea of the Wi-Fi routers on campus, and how these Wi-Fi routers can be breaking every once in a while, and we have to diagnose that. So we got a lot of positive feedback, and thanks to the hackathon that kind of stirred and pointed me into the direction of coming to talk about problem solving in games and things like that. So great. Now, I want to congratulate everyone here today for achieving a very significant milestone. You're probably staring at me and thinking, this guy lost it. What achievement we've done? Let me show you. Let me prove to you. So today I'm going to be using the whiteboard a lot. So let me tell you. First thing when we learn here, we learn about something called the built-in functions, right? Can somebody give me a name of a built-in function? Yes, sir. Print. Okay, that's the easy one. Can somebody give me another one from the weekend? Yes, sir.
The int function?
Yes, yes. But before the int, there was another one that kind of triggered the int to be taught. The input function, exactly. So we learned about the input. And as a result, we learned how to work with the input coming from the input function, which was actually int if we are converting the input into an integer. Or what was the other one that we worked with? A float, right? So these are the very basic input built-in functions that we worked with this from the beginning of the semester, right? So all of this is great. Now what? We started to work also doing some very basic printing of, say, like printing hello world, hello class, hello guest, hello everybody, right? And then we also started to do a little bit of operations. So we actually, with that print function here, we started to add these syntactic devices, right? We had a message here saying 2 + 2. And we wanted to know the actual value of 2 plus 2, right? We had a comma here, and then we added 2 plus 2, like that, in a very elementary way of doing programming. And that would print a message that would give me, that would say 2 plus 2, which will be very basic, right? And then this function showed us that we can do great things, except that we're very limited on the operations that we can do, right? So this is introduced us naturally into another place where we actually worked with little boxes. We call them piggy boxes to be a little bit cute and friendly at the beginning of the semester, until we eventually landed the real name and we called them variables, right? So we started to define variables. And when we define a variable in Python, we define a variable for a price, as we saw in the assignment, right? And the price is like, I don't know, $10, $92 is your favorite number, correct? We also worked with another kind of number, which was a fraction. We defined taxes, tax rate, and say that was 14%, right? So we started to be a little bit more clever to say, okay, I want to multiply the price by the tax rate, so I can get the tax value. Okay, that also introduced us to some interesting things, some interesting devices. Introduced us to operators. So the operators that we used were very basic arithmetic operators. We used the plus, we used the multiplication, and it's a star, right? In Python, the multiplication is a star. And we also did a discount in the previous lab, so we actually used a negative sign number, right? Or a subtraction with a negative number to subtract. And what else did we do? When we did the average, we divided, right? Okay. Are these the whole operators that we've learned? Not exactly. Because as you can see, let me highlight this. As you can see here, I used an equal sign. What does this equal sign? You're shaking your head as if you want to tell me what you want to tell me. So tell me what you want.
This one equals this one.
Exactly. So what he's saying is, I really want to put this value in here, which is, this is the assignment operator. This does not assert equalities, right? And this exact same device here means that this guy is deposited in the left-hand side. So the right-hand side of this operation is going to be stored in the left-hand side. Okay, so we talked about the equal sign, and we know that it's not equality. And somebody tell me what equality is about. Or what does equality look like? Yes, ma'am.
It's 2 equal signs.
Exactly. So if you want to test the equality of something, there will be a double equal sign. Correct? This is how you're going to test. If I have a number here for my price equals 124. 124. It's a hypothetical number, any arbitrary number. But this is going to ask the question by using an if statement that would say, if this price equals this, and that also takes me to the next level. But not next level, we're asking a question. And we're asking a question, how do we do that? We say, if it is this, we're going to have to take an action. So this presented us to another device, which is a conditional. Right? To make decisions. If the price is 124, then maybe you pay a higher tax. Or maybe if the price is on sale, you get buy one, you buy one, you get 2 for free. You get 2 for free. I don't know. But these are the exact same conditions that we have done. Are these the only operators that we work with, especially from the assignment that we? So you want to tell me which one?
The remainder of the percentage?
Yes, that's a very significant one too, because it is in your assignment and we still have to submit that tonight. So what Nate is saying, it's related to the division, except that it's not a division, it's a modulus operator. And the modulus operator allows me to divide a number by another number, giving me the remainder. And what we use that for is to ask for a question, a very significant question. It's on your assignment. Elizabeth, you want to tell me?
Even or odd.
Yes. We basically want to give a number. We want to get a number, okay? And this number is going to tell me I am odd or I'm even. How do I do that? I take that number, say my number is 3. Okay? That's an odd number, but I want to make sure that when I use Python, I know this is going to give me an odd or even number. So I'm going to divide using the modulus operator and divide by what? By 2. Exactly by 2. So this is going to give me what? What's this going to give me?
1.
1. The remainder is 1 because this is what? This is odd. If I have 4 modulus 2, this is going to give me what?
0.
0 because the remainder is 0. Correct? And for those who are sitting here in my CS100, this is exactly the same mechanism that we used to convert numbers into binary from decimal. This is a decimal number, make no mistake. We didn't say it's anything, so we assume it's the default by default. It's a decimal number. So if we continue to divide by 0 and take these ones and zeros, so if we have a number like, I don't know, like 9, and we continue to divide here, the last number here is going to be 0, and then a 1, 1, 0, 0, 1. So for my CS100, we know how to write this number, because this is the most significant, and this is the least significant. As a matter of fact, I'm giving you a hint for your next assignment, perhaps your next lab. So that's how we're going to continue to build with the skills that we're learning here today. Okay? And if you're sitting with me in CS100, you think that these are theoretical things we're going to just do on a piece of paper. No, when you come to here, we're going to be doing these things here too. Okay, so these are the operators that we've known. Great. We also talked about the input function. The input function was a very interesting one because it does not, it frees me from the hard coding of things, right? If when I'm testing the functions, say I have a simple function, simple sum function. And this number is going to take 2 and 4. And it's supposed to be returning the sum, which is actually 6. Okay? When we're testing this function the way it is, we're plugging in numbers in this form. We decided what numbers to plug in advance. And in programming, that's acceptable on your level. But now we've learned a new device, which is the input device. So the input device can tell you, enter the first num. And then what are you going to do? You're going to store that number here. That would be num1, right? Then we're going to get another input. And we're going to be asking, enter the second num. And this is, you're going to be typing a number from the keyboard, right? This is going to open the console for you. And then you're going to be storing this number in a variable. We're going to call it num2. But this frees me from hard coding these numbers, right? I would never be able to, I would never need to hard code any number again because I know now that I can get them in any program I want and ask people, ask the user who's going to be using my program to enter these numbers, right? Here's what happened when we used this function, when we said n1 num1 plus num2, that was supposed to be giving me the sum, correct? If I read these guys just like that, what kind of sum I'm going to get?
24.
Assuming exactly. Assuming that I'm entering in the first value, I'm going to be entering 2. And in the second value, I'm going to be entering 4. So this function, just as it is, my sum is going to be 24. And for those who are confused, I want to ask you, why do we have this result here? That does not make sense. This is not, yes, Mushir?
You have the result there because it's coming in as a string instead of an int.
Exactly. Did you guys hear that? So what Lucia is saying is, if we take these numbers in the raw form without doing anything about them, they're going to come as symbols. So Python is gonna give me this number as a symbol of number 2. And this is gonna give me the symbol of number 4. And it's gonna add these symbols together, not in any mathematical way. So it's gonna show me that these guys are gonna look like 2 next to 4, which is gonna give me this number. How do we fix this? We learned in these built-in functions, we have some conversion utilities. And we said these built-in functions are already there for us. We don't need to import anything. We don't need to go download the library. This is part of the Python. When you download Python, these are your best buddies, right? So now, how am I going to work with these numbers so I can get the sum here to be 6 versus 24? How do I do that? Nate,
You need to call a function and then like use the plus operator.
which function is that? Look here, it's right here, right? Exactly. So what we're going to do, we're going to call these conversion utility functions. I'm basically saying, okay, so instead of using these symbols, I know that I already entered the number. I'm just going to do something that is known in other programming languages, like Miscat here. You guys do something called typecasting or conversion. So here, because Python does not convert any types, it just gives you that and then emphasizes the type after. So what we're going to do here is we're going to add the int. The function here is going to be taking that symbol here and is going to return a numerical representation of that symbol, which is going to be 2. Okay? So now if I apply the same thing one more time, 4, like that, this is going to give me 4. So now when I add these guys, 2 plus 4, that's just going to give me what? The proper results. Okay? Are we okay with this? All right. So these are, and then we say we enter the price and we enter a floating point number or a decimal of a fraction, 24% or 14%. We are going to be using the float function as a, yes, sir.
Can we go back to the integer for just one moment? Where in the code would you put that, would you place that function?
Very good question. Very good question. Remember when I actually asked you before you guys do the assignments, there was a video of 5 to 10 minutes, correct? People are shaking their hand and I saw the many views and I'm very happy that you guys are utilizing these resources. Every time you guys come here to class, before I sleep, I record that video, I post it on YouTube and I make it available for you so you never forget. So I have the answer there, but I'm happy to give you the answer today too. Here's what we're gonna do. The input is like that. This is how I'm gonna call this input function. We'll have a message enter such and such, right? And here's my number 1 variable, correct? Now how am I gonna work with this? This is the one that uses a symbol. Say this is using, I entered the value 2 here. So this is gonna be a value of 2. And you see how I'm using the quote unquote? Because that's not a number, that's a symbol. Okay, so here's how I'm gonna use it. I'm gonna take this int function like that, and I'm gonna pass the num1 like that. And I could actually call this immediately with a plus sign and then do the second number. I apologize. So this could be, say, my float if I'm using a tax rate or a discount. So that would be num2 or tax or fraction, however you want to call this. These two guys can be immediately plugged in, and that's going to give you a value. You could be more meticulous and do it this way too. This is an int here, right? You could be more meticulous and do int of the first num, like that, and you store it in a converted num. And new n. Okay? And you could do the same thing here. You do a float. And this is your rate or whatever variable name you call it. And that's gonna be stored in a new variable you will be creating. That's gonna be the converted common rate. And now you have the converted rate, you have the converted price, you multiply it together. So this is how we're gonna be doing. You know, I'm gonna use a different color. So now I'm gonna use the conv num times the common rate. And this is gonna give me a real numerical value. It's not gonna be a symbol anymore. Any questions so far? I find you guys have a great understanding of everything, except when it comes to the final finishing touches, when you actually test your functions. Still, these questions are, these loose ends gonna be remedied, and I'm happy to help anyone in office hours. Or, yes, sir.
I was curious, if you have a function up top, so if it's calculating percentage, is it correct to put the int or float in the variables of in the function?
Okay, so you're bringing us to the next component, which we talked about built-in functions and operators. Now we're going to discuss the next component that you guys worked on. Which is actually functions. And I told you, if you mastered functions, and so far you guys have been doing really great, and I'm so proud of the work that I've seen some mind-blowing work, and I've given you a sample from a student for the work you guys have been doing. So let's talk about functions. I'm gonna define that simple sum function again, because that seems to be a key concept that still a lot of people do not get. Let's work with how do we define a function? Yes, ma'am. Def, exactly. And the function should have what? A name. Thank you. So we're gonna give the function a name. We're gonna call it simple underscore sum. And make no mistake, this function is going to take what? Parameters. That's right. And the simple sum is only gonna take two values. N1 and N2. Okay, yes, sir.
So can the parameters be anything?
So far, you're asking a very good question. Python does not force you to define the variable like other functions, like other programming, like Java. You would actually say in Java, int num, and then you put a 0 or a 1 or 100, whatever. Python does not. It's a non-type. This is the name. Again, this is an advanced concept in programming, the theory of programming languages. Python does not tell you need to define this as an int. Python tells you, tell me whatever you want, and whatever you put in it, I will make something out of it. So here's a very good question. So suppose I'm going to do num like that, and then I'm going to put 1 like that. What do you think? You think Python is going to say, oh, this is not exactly a 1. This is just a word that says 1. Python is not going to care. But Python is going to declare this one as a stream of characters, which is actually known as a string. Okay? And this one, as soon as you put a numerical value in it, Python is going to be putting in their dictionary in the background, saying this is a variable that is numerical right now. But as you can see, this could be a very confusing thing because you don't know which variable is a number, which variable is a fraction, which variable is a. But there is a solution. I actually came from a strong Java programming background. And this was one of the most hurdle things for me, not knowing the type of the variable that I'm working on. Especially if you're working with somebody else's code, you never design yourself. But there was a very clever built-in function that's going to tell you every time you want to work with something, it's going to tell you what it is. You want to guess what it is? It's going to tell you what type this variable is. You want to guess this function? It's called type. It does make a lot of sense. Now, if you create this variable, okay, and you invoke this type function on this num, it's going to tell you this is an int data type. Okay, this is an integer data type. if you invoke this function against this num2 here, he's going to tell you this is a string data type. Okay? Makes sense? Okay. So now back to the question that Chandler asked. Chandler is asking to clarify some issues about functions and how functions are being called, tested, and so on. But before I move on, how do I make this function declared correctly or created correctly? What is it that I'm missing here?
Column.
What's that?
Column.
Column. That's right. Now, as soon as I do this and hit enter, Python is gonna force me to move to the right. Indentation matters in Python. In other languages, nobody cares. Okay? Some recent frameworks, like the Java Spring framework, it does enforce the number of characters you have to indent because it creates objects out of those. Python in this scenario forces you to do the indentation run. When we're here at the hackathon over the weekend, I believe Rowan, who's not here today, is in another class. That's from my CS100. Was actually having a serious indentation problem. And it was just an indentation problem. It was not anything other than that. So now, what we're going to do with this simple function? We know that we need to add these guys together, right? So I'm going to be working with this guy and that guy, adding them up, right? So this is going to be my n1 plus n2. And if I remember to do things right, I'm going to be storing those guys in a variable. I'm going to call it sum of. And why sum of, not just sum? You want to tell me? Why am I using sum of versus sum? Because sum is a reserved keyword. Cannot use it. I can use it for some things, but I cannot use it for a variable name. So sum of these two guys, and then when I'm done, is there anything else that I'm missing here to actually be able to finish this function and be able to use it? What's that?
Return.
Exactly. So I have to have a return statement. Return. Let me use a third color. I'm feeling generous. So here, sum of. Okay, this function now is ready to be executed. It's ready to be called. Okay, here's how we're gonna call it. You're gonna leave out of this body of the function, because if you put the function here, you're gonna be calling the function on itself. This has been an error here from somebody who's not here today. If you do that, the function is going to continue to call itself a recursive, and we don't want to do that. We have to call the function at the same level here. And what's the name of the function? Simple sum. Simple sum. And for the sake of the speed of what we're doing, I'm going to be doing 2 and 4. And what am I going to do? Here's what tricks everybody. When you call this function here, you forget, you only want to print this, but as soon as you print, you lost the return value. So what you're going to have to do is to get the sum value here, declared. Now we can work with this sum, correct? Now we can actually start printing the sum. Good. Are we okay with that? Chandler, are you okay so far?
Yes, sir.
Okay. Now what? I've given you another function in the previous lab, not in the assignment, but yet in the lab. This function was actually called, let's call it brilliant sum as opposed to brilliant average. It's just one less thing to worry about. But the idea now is to demonstrate how to create functions and how we use them and recycle them over and over. Now I'm going to create another function, and I'm going to write it quickly. So I have to define the function, right? And I'm going to call it brilliant sum. And this function takes 4 values, not 2 values. It takes n1, n2, n3, and 4. Okay? And I told you in this lab You're only allowed to use one device. This simple sum here. You get everything done. And people scratch their heads, but I'm so proud you guys figured it out. It was really, really great. Okay, so how did we do this? We used a simple sum. Sim sum, like that. And we plugged in which variables, Bashir?
N1 and N2.
Yes, exactly. So N1 and N2. This is going to give me what? The first sum. Now I'm going to repeat the same operation again. I'm going to do 3 and 4. And this is going to be my second sum. And by the way, first and second are not valid variable names because they start with a number. So be careful here. For the sake of what we're doing, I just want to demonstrate this, that when we're writing the code, this is going to be different. Now we have two sums. Are we done? We're not done yet. What do we need to do? We need to add these two sums. Okay? So I'm going to have the first sum, and I'm going to add the second sum, and this is going to be my final sum, right? Now what do? Print and go home? No, bad idea. We need to return the value. If you print, it's going to work, but all this work will never be recycled again. The whole idea of creating a function, remember, especially for my CS100 or studying problem solving, you got to realize that programmers, smart programmers, they create devices and they use them over and over and over. Okay, now we created this device and we created this. For us to use it again, we have to return the value. This is another problem that you guys still have not mastered. You do all the beautiful work, and then when you test, you expect the function is returning something. The function is not returning something. Okay, so that's what we need to do. We're going to have to return what? Final sum. Okay, now this function now is good because it has done everything it needs, right? We can call this function like we call the simple sum. There won't be anything different about it after we designed it. The only thing that will be different is that this function is going to be taken brilliant sum is going to be taken the actual values, right? 2, 3, 5, and 10. That's going to give me what? It's going to give me what? 2, 3, 5, and 10. It's going to give me 20, right? So now I'm going to store this 20 here. Find sum. And this is going to be the actual value when I call a function like this. I could call this function again, right? Brilliant sum with different values. Is there anything that should stop me from calling this function 100 times? 1,000,000 times? Imagine a professor was calculating your grades, okay? And he needs to calculate everyone's grade, every student's grade from 4 labs, okay? So they're gonna have to do the same sum for you and her and everyone, right? So it does make sense to call this function more than once. That's why you define the function. So here's a 1, 2, 3, and 4. That's gonna give you what? Come on. It's going to give me 10, right? Okay, so the second final sum here is going to give me 10. But I want to tell you a secret. I want to tell you that something inside me is telling me that this is programming. Something is terribly wrong with it. And I'm going to tell you why. I have to do all this work to add up 4 values. And I have to call those guys 3 times. And suppose I'm asking you to calculate, instead of 4 labs, you're going to have to do 10 labs. How many functions you're going to have to call here, right? There will be so many. And I just told you something about Amazon the other time, right? Amazon has all these products and they do all the math and all the pricing for it. So it's not just about 10 or 5 or 4, it's gonna be millions of things. So what if I want to add millions of items or millions of numbers of the prices of numbers, prices of items? This function is not gonna scale. This function now is going to fail. So I need right now something that will free me from the slavery of this function. That is only taken 4 because I cannot continue to type this forever. It does not make any sense to me, right? So now I'm going to tell you the good news. The good news here is Python does not have to take individual values. Python can actually do, like when you go to Costco, you buy things in bulk, right? When you buy things in bulk, what happens? You can get them all together in big box, right? So Python can give you things in bulk. So suppose instead of getting these individual 1, 2, 3, 4 values, or 5 or 10, I'm going to give you a bulk of values together. And it does not matter how many values in there. I'm going to be able to teach you how to work with this. But first of all, this is now seems to be like I can breathe. I'm going to process things. I don't have to worry about processing these functions and typing them every 2 values and then adding the 2 to the 2s and 2 to the 2s. It's a nightmare. And now I want to show you if we have something in bulk like that. Okay, how do we do that? But before I go into the functions, I just want to continue to make things much simpler. And let's see how we do things in bulk. Suppose I'm giving you this pigeonhole, whatever you want to call it. And anyone wants to give me any random numbers? Yeah, any random numbers to stash into those guys? Yes, sir.
52.
What's that?
52.
52. Okay, anyone else? 7.
4.
4.
6.
6. Anyone else?
21.
21.
20.
20. What's that?
93.
93, is that what you said? Okay. 93, 9, 0, 7, 8. Okay, now I did not tell you what this container is, and I'm not telling you anything about it yet. But suppose, because Nate, you started with the first value, how do you read this container of values? How do you read it? If I ask you to read all the values, where do you begin, where do you end?
Usually left to right.
Can you read? And I'm going to write everything you said. So Nate is going to read this box of things to me, and I'm saying of things because they are things, okay? And I will explain in probably future lecture. So Nate, you want to tell him?
52.
52,
7.
7,
4.
4,
6.
6,
21.
21,
20.
20,
93.
93,
9.
93, 9, 0, 7, 8, 10. You don't have a 10, Professor. Come on, why do you have to invent? This is when we need to stop. And this is when we need to begin. Everything has a beginning, has an end. Okay? So now, if I tell you, what is the first number in this? You would tell me first number, Professor, is right there, is 52. What is the last number? Can you count? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The number at the 11th position. That's my last number, right? Okay. Now if I want to tell you, give me the number on the third element. Give me the number on the third element. Which number that would be? 4. So far, you guys are not doing programming. You are doing common sense, right? Now I'm going to tell you. I am not going to start counting these guys or labeling these positions from 1. I'm gonna start, yes,
So you're gonna start from 0, so 6 would be the third.
6 will be the third. Well, it really depends if you are talking about the third position or the third index. But yeah, but you are thinking ahead of me. Very good. Hold on to that thought. So if I label this position, that is going to start from 0, when do I stop? How many of those? How many of those do I have? We said 11, right? So I'm gonna stop at 10. That's right. That's right. So if I tell you, I'm gonna call this guy bulk numbers. Okay? Now I'm gonna tell you, give me the third number here. What position that would be? Second. The third would be the second. Okay? The third position, 0, 1, 2. Correct? So here's how I'm gonna tell you if I want to get that third position from this list. Is there anything that should stop me from saying bulk underscore numbers? Now I'm gonna get the third position, which will be. Is there anything that should stop me from writing this the way it is written right now? It's just something that makes me feel good. Okay? Is there anything that stopped me from saying, I want to get my first number, and my first number is going to be bulk underscore 0, which is, by the way, 52. Okay? Which is 52. So the first number that we attempted to get was the second, was actually the third number, which was at index 2 or position 2. Position 0, 1, 2, which will be 4. That will be the value. Now I'm going to ask you, can you give me the last element? What would be the last element? It would be the length, this whole bulk thing, minus 1, right? If I know those guys are 11, so the last one is going to be 11 minus 1. So suppose I'm telling you there is a utility that takes this bulk numbers like that, and this is going to give you the length. And if I do minus 1, that's going to give me the position of this guy here. Now, I'm going to use this bulk number here. Bulk num. I'm going to use this square thing. And guess what? This is how we can reference the last element of a list that has 1,000,000 numbers. Of a bulk items like that in a 2,000,000 numbers or items. As long as you know the length and you can calculate the length. Now I'm going to show you another interesting thing. One of the built-in functions that we added, we used here, we have 5 of those. 5, now I'm going to add len, which is a function that is designed to give me the length of a bulk container like this. If I tell you, Python has a special name for this guy and calls this guy a list. Do you agree? Yeah, it's a list of things. This could be a list of prices, list of barcodes, list of students, list of movies, list of laptops, list of chairs, right? So Python refers to this as a list. And this is the gateway to doing things in bulk. This is now, you'll be freed from the slavery of the simple sum function, or the brilliant sum, because you don't have to call things a certain way. Now, do I have to how much time we have? We have 6 more minutes. I wanna take a chance, and I start doing things on the laptop. Okay. Thank you, sir. So I want to take a chance today to introduce you to this concept on the machine. Okay? I'm going to create a list of 3 or 4 things just to demonstrate. Python. Now I'm going to create a bulk. Bulk of numbers. Now I'm just going to create 3 of those guys. So I'm going to have 2 and 4 and 7. And as you can see, we use the same notation that we use here. We use these square brackets, right? And we separated the numbers that we have added in that list. If I press enter, thank goodness I didn't get any errors, right? But Pat, let me show you now, because we did not do this before. Let me show you what Python is going to point at this bulk number variable. Do you think this is going to be a number or a string or anything that we've never known before? Let's try. I am thinking, and who agrees with me, that this is going to be a list. That's what I'm thinking. But let's see if the type here is going to give me these bulk numbers. And it says a class list. Okay? So this is the first time we demonstrated how we use this specific function, because we did not need it before. Today we've been introduced to a list of numbers, and it's not going to be only a list of numbers, like I said. This is going to be a list of everything else. List of characters, list of words, like we played Hangman over the weekend. Okay, we used a list of words. Now, who wants to tell me what would be the first value? How do we get the first value here? What's that? 0, that's right. So if I use these square brackets and mention the name of that list or the bulk numbers that I created and put 0, it's going to give me 2. And this is indeed the right value in the first one. What about the last one? The last one I know from looking at 3 numbers is going to be at index 2. Right? Good. What would be the second number? Second number would be the one in the middle, the one at index 1, right? Just let's be done with all of them. Okay, Professor, you told me that I can use this length function and I can calculate the position of the last element without having to memorize. But I only see 3 things, and I don't need to memorize. I can spot it, but if you give me a list, I'm going to use this list again, but I'm going to add more numbers. 3, 5, 10, 2, 1, 3. And I was not counting how many elements I have here. Okay? Now let me show you how we get the length of this bulk number. I have 9 elements here. And if we calculate them, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. Exactly 9. Okay, Professor, you told me that I can use len minus 1, and that should give me the position of the last one. And if I put the position of the last one with the list, I'm guaranteed to be getting the number 3. Would you please show me this? Sure. So let me show you first. Now I'm going to call the bulk number. We have to refer to the list that we created. That's why we have a name for it. Now I want to get the length of the bulk numbers minus 1. All of this jazz is going to go into the square brackets. And if I do things right, it's going to give me 3. Who agrees with me here that this is the right value? Make sense? Okay. We're coming to the end of the class, but this is only the beginning of using lists, which are also known for those who are doing C++ and other programming as an array. Congratulations, you have achieved a great milestone today. Please turn in your assignments on time. You still have questions, email me. Please don't email me about me. What did I say about emailing me at midnight? Not to, right? Especially when you're about to push that submit button. Okay, I want to make sure that everybody gets a fair chance to work on this assignment. Hopefully this clarified everything today, and we're going to continue on Wednesday, the journey of our of this. Thank you, everyone. Yes.
You don't need to go.
But here we're using numbers, because this computer is a bit smart enough to convert them. Yeah, there was no.
Okay. Okay, thank you.
This is okay.
Thank you.
You can, anything that uses. We're working with this, all these efficiencies will be like.
ES3.
Yeah.
For my dad. It's like my